A thing. Function is a thing.
I know it has to pass the vertical.
Okay, that's something. Has to pass the vertical line test. So it's basically a relationship where each input has exactly, girls good? One, you're welcome, output. In terms of our equations, that means x never repeats if you're looking at a set of ordered pairs. If you're looking at a graph, that means it passes the vertical line test. So basically, when you do it, you get one answer and only one answer every single time. You can't get multiple things out. So let's look at the graph of a function. And why do I know it's a function when I look at this? That's the vertical line test. There's nowhere I can draw a vertical line that hits it more than once. All right, we're going to answer a bunch of questions from this graph. Find the values of f of 1 and f of 5. Function notation, what does that mean? What does the 1 represent? The x value. So it's basically saying when x is 1, tell me what y is. So I go to my graph. I find the place on it when the x value is 1. And we're right here. What's that y value? So f of 5 says when x is 5, tell me what y is. 2/3 even ish. Everybody's good with that? Knows where we got those? Domain and range. We did interval notation in college algebra and trig. That's what we will continue. So domain is talking about the possible x values, so going from right to left. So it kind of depends on, if these had arrows, we would assume it went forever, which, what do we put for it goes forever? Okay. Since I can see past those points on the graph and there is nothing, we would assume that this is the start and this is the stop. So it starts when my x is 0. What do we put, parenthesis or bracket? Bracket. Remember, bracket means equal to, parenthesis, not equal to. And then it goes until we get to x equals 7. That would also have a bracket. Range is referring to the y value, so that's bottom to top. So the lowest point on our graph is when our y value is and the highest point on the graph would be when the y is that okay? C. Local maximums and minimums. All right. I think we know what a maximum and a minimum is. What do I mean by local? Right. It doesn't have to necessarily be the highest or lowest on the entire graph. just higher or lower than the surrounding points. So it's been a little bit, and we will talk more about this later on in calculus, so if you're a little rusty, it's okay. If I gave you a graph like this, this would be a local max, and so would this, but this one would also be, do you remember what we called the highest on the entire graph? It's an apex, or we called it, in some situations we use that. We could also call it the absolute or the global max. Local minimums, we have two, here's a local min and here's a local min, but this one would also be the global or the absolute minimum. Just as a little fun fact, we will go back over those. But just the local maximums and minimums, that doesn't include endpoints when I'm talking about the locals. So just basically the highest or lowest ones that we see. So we only have one local max here, and is the highest on the entire graph. Let's write that in function notation. So what's the x value? 2. So f of 2 equals 4. You could write it as an ordered pair also if you preferred. Just want you to be comfortable with both. Okay, the local minimum is right here. So if I did function notation, what is that x value? 6.1, 6.2-ish, something like that. And that is equal to -2. Or for local maximum, you're welcome to give an int or an ordered pair as well. Either notation is fine. The roots or the zeros, what are those? Where it hits the x-axis. So root, 0, x-intercept, solution, those are all the same thing. So it hits the x-axis at 4.5-ish. Anywhere else? Increasing, decreasing. Remember we did intervals for that? We use the x values. So starting here, when my x is 0, it's increasing until we get to 0 to 2 would be increasing. And then from 2 until we estimate that to be about 6.1 earlier, the graph was falling. And then after that, from the 6.1 to 7, it is increasing again. Do you remember what we put if we had multiple intervals? Technically, with increasing and decreasing, it doesn't matter if you do parentheses or brackets. So both are correct here. All right, how much of this stuff are you remembering seeing before? Somewhat familiar? All right, so one of the biggest things that we will do once we get into more calculus out of our review thing, we're going to be finding something called the difference quotient a lot, which basically just involves being able to use function notation and simplify. So we are going to practice that a little bit. First, we're just going to start with function notation and making sure you remember what this means and how to reduce that. So if I gave you a function, and then I asked for f of -2, what does that mean? Yep, you go to your equation, you replace all of your x's with a -2. In class, guys, you are welcome to use calculators. Grab one if you need it. Like I said, tests and quizzes, I make sure everything's nice and pretty. In class, I don't. So we're going to use them if we need to. So -2 squared would be 4 times 12 minus negative, so plus 2. Plus 2. So we get a 60. F of a plus 1. What does that mean? So the x gets replaced with an a plus 1. Notice I'm writing it in parentheses so I can make sure I distribute everything I'm supposed to. Alright, so 3. A plus 1 squared. What does that mean? Yeah. It's like saying you have a plus 1 twice, so we have to FOIL that. So you get a squared plus a, so plus 2a plus 1. Okay, here I need to distribute my negatives, so minus a minus 1 plus 2. 3a squared plus 6a plus 3 minus a minus 1 plus 2. So then all like terms gives me 3a squared, 6a minus a, so plus 5a, 3 minus 1 plus 2 is 4. Do you guys want to try the next couple? I know sometimes it's hard to squeeze things in. I do try to remember to put extra slides, but I apparently did not on this one, so squeeze it in the margins or whatever. The next slide we won't really be writing anything on, so you could use it if you needed to. So the first one, did you get 27a to the 4th minus 3a squared plus 2?
Yes.
And D, not necessarily hard, but more time consuming. You have to plug in that a plus h. So if you FOIL, would you guys mind it? Can I FOIL and distribute my 3 at the same time?
Yes.
Okay, no like terms, so that's it. You could have it in a different order. Did I lose anybody there? When you do the a plus h squared, you get a squared plus 2ah plus h squared, because you have to write twice in FOIL. And then distribute the 3. Okay, so we can do those. If you can evaluate functions like this, then you can do a difference quotient. So a difference quotient, something we will do a lot of this semester, is f of a plus h minus f of a over h. I think we did a couple of these in college algebra. I just never told you it was a difference quotient. I would say part A, find f of a plus h. Part B, find f of a plus h minus f of a. Part C, find the whole thing. So we kind of broke it into pieces. We can do it in pieces like that, or we can do it all together, just kind of whatever makes the most sense to you guys. So I want to try a few of these, and we will be getting lots and lots of practice with it, but right now it's just a matter of doing the algebra. So I want f of a plus h f of a all over h. Right now, on a test or quiz, if I asked for it, I would say find this. I wouldn't just say find the difference quotient and expect you to remember that formula right now. Okay, so I would give it to you. So it's just a matter of evaluating those functions. So what do you guys prefer? Do you want me to break it into pieces, or do you want me to try to do the whole thing at once? Try it. Just do it. Let's try the whole thing. If I lose you, tell me and I'll do another way. Okay? So, first thing I need, f of a plus h. So I have to plug a plus h in for my x. So that's this piece. Minus f of a. All that says is you go to your equation, you replace your x with an a. All over h. So if I distribute, take the negative through the second one. What do you notice? Yeah, you're always going to have a lot of stuff cancel out on this. If you don't, you have a mistake. Negative 4a and positive 4a cancel. Positive 5 and negative 5 cancel. So I'm left with negative 4h divided by h, negative 4. All right. So they get longer with uglier equations. Showing your work is really important, not because I expect you to write everything down, but people tend to make mistakes when they don't write something down. So if you're one of those people, write what you need to, okay? So this one, f of a plus h. So I'm going to replace my x's with a plus h. Minus f of a is always nice, you're just replacing the x with an a. Over h. So now we have to multiply this out. This is where it's kind of up to you how much work you want to show. Am I going to lose you guys if I distribute my 2 and square that a plus h at the same time? So I know if I take my a plus h times a plus h, I get a squared. So if I distribute the 2, that's 2a squared. I would have plus 2ah, that would turn into 4ah and 2h squared. Does everyone know where I got that? I can show more if I need to. This one I distribute my negative 5. And then I take a negative through that whole green parenthesis. All right. So what happens? Cancel stuff. 2a squareds drop. 5a's drop. 1's drop. So I have 4ah plus 2h squared minus 5h, all divided by h. Yep, you have to take an h out of each term. So that gives you a 4a plus a 2h minus 5. that okay? So a lot of algebra in one problem, but all things that we've done before. Last one. F of a plus h, you're going to replace that x with an a plus h minus f of a all over h. If you're out of space, I think the bottom part of that page is blank. You can work it out there. Okay, this one's kind of nasty. If I need to add or subtract fractions, what do they have to have? Common denominator. The first one has a plus h. It needs a plain a to look like the other one. So I have to essentially multiply by a on top of that. Second one has the a, it needs an a plus h. So we get negative 3a over a times a plus h. Minus negative, can I go ahead and make that plus? 3a plus 3h over a times a plus h. All right. Now, these denominators match, so we can put those fractions together. When I put them together, what happens? Negative 3a plus 3a drops, so we just get 3h for a times a plus h. Okay, this is like an h over 1. How do you divide fractions? Flip and multiply. So I would say I could take this times 1 over h. What happens then? H's drop. You get 3 over a times a plus h. Sorry. Questions for me?
Where did that 1 from h, 1 over h come from?
So the divided by h on the bottom, I said that's the same as h over 1. And if you have a fraction divided by a fraction, you can flip and multiply. Other questions? So this is something that we will get lots more practice with later on. Just a couple more examples. I want to try to wrap up here in the next 5 minutes or so. All right, so here's an equation. I want to find f of negative 2. This is a piecewise function. How do I know which one to plug it into? So negative 2, isn't that less than or equal to negative 1? So I plug it into the first one. So 1 minus negative 2. And I get 3. F of negative 1. Which one do we plug negative 1 into? First one again because of the equal to. So 1 minus negative 1 is 2. F of 0, which one do we put 0 into? So 0 is greater than negative 1. So 0 squared is 0. How do we draw graphs? Especially if you don't have a graphing calculator. How'd you do it, you know, back in the olden days before you knew what graphs looked like? What'd you do when you didn't know? Yeah, and then you made T-charts, right? So let's see. If I want to graph this first piece, where would we have to start? What would have to be the first thing I plugged in? We'll go ahead and start with -1, then we do things smaller. So 1 minus -1 is 2. 1 minus -2 is 3. 1 minus -3 is 4. Does it start with an open or closed circle? Closed because I had an equal to. So it started at this point and it went to the left because we were doing less than. Second piece. We still have to start with -1 when we want things larger, but what's going to happen when I put the -1 on my graph? It'll be open because it didn't have an equal to. Alright, so -1 squared is 1, 0 squared is 0, 1 squared is 1. So -1, 1 is open. 0, 0, 1, 1. If you didn't know what it looked like from here, you could always put in more. If you put in 2, you get 4. So we see we started here, and then we're getting a parabola. This is where I'm stopping today. We are not quite done. So I haven't talked about domains yet, but we will tomorrow. So I am going to give you a handout. This handout will be due on Friday. Okay, so today's Wednesday. This is the homework for today and tomorrow. You already know how to do a lot of it, but we will also probably have some class time tomorrow as well. Are there any questions over anything on today?
Oh, wait, I have a question.
Yes.